Here we're going to look at this gearbox plate. This is from one of our older robots. And in the past, when we've looked at machining plates, specifically the 135-degree gusset, we used basically a sacrificial plate that we clamped our stock to, and then the part was machined out. And you can look at the previous assignments for that. However, what we found when doing that with gearbox plates such as this is when you clamp one plate down to another, often the stock plate gets slightly bowed. And that has a real effect on things like bearing holes, etc. And so we have a different technique for machining plate material that has bearing holes in it, and we actually use what we call a fixture plate that we've machined specifically for this purpose. And often in a fixture plate, we actually machine several pieces at once. For this assignment, you only need to do this opposing gearbox opposing plate. There is a bonus option where you can do two plates on the fixture plate. In this first video, I'm just going to talk about the setup, and then we'll go into other videos on the actual machining techniques. So the first thing that we're going to do is we're going to create a new assembly, standard.iam, and go create. We're going to actually be doing our computer-aided manufacturing within an assembly, not within a part. And we're going to place several things in there. First, we're going to hit place, and you're going to find the fixture plate that we're going to be using. You should have downloaded this with the assignment. It is the 9x18 fixture plate. And then go open. And this is something that we've just machined in our shop, specific for the purpose of making these flat plates that have bearing holes that give nice results. And so this is actually 9 inches wide, 18 inches tall, and then 2 inches thick. And it is bolted to the table of the mill through these slots here. We just use large 1/2-inch socket head cap screws that go through into T-nuts that are on the table. And I'll show you that in the shop. But basically, that is what this is. This is actually the smaller of the plates that we have, and it was initially designed to fit on 2 different milling machines. However, now we really just use it on the large milling machine, and this, where my cursor is the y-axis, and then the short 9-inch is on the x-axis. And so we have room for this and 2 additional vices on the machine. That's usually what we keep on the machine. So that's the first thing that we're going to place. And then what I like to do is ground this so it doesn't move. So I'm going to right click over here, and on the drop down, left click grounded. You can see that there's a little thumbtack through that, and then the part doesn't move. Now we're going to place a couple of other things. The next thing that I want you to place is the actual stock. This is basically what we are machining the part out of. If you remember in the past, we just used a stock setup, but I'm going to show you that we can actually just use a separate file for stock. So that's what this is right here, 9x18 by 250. The 250 means 1/4 inch. Okay, and so I'm going to go open and place this. And then the next piece we're going to place is the actual part we're machining. And I have that in a separate folder. And I don't know how you've organized your parts, but I have my parts in one folder, and then my fixtures and things like that in another folder. We're going to put in the gearbox opposing plate. Now, if you're doing the bonus, you can put in both of these plates, and I'll put both of them in right now, but I'm only going to really show the setup for this one. So again, if you're doing bonus, you would be placing both of these in at the same time, and we would lay those out on this plate. So the next thing that I want to do is position everything. So what I'm going to do is use some constraints to place this stock material directly on the fixture plate. So there's several ways we can do that. We can hit C for constrain or hit the constraint button, and I can go maybe under here and mate that face with this face, and it makes a little sound. I can hit apply. Then I think it's easiest if you just use the flush constraint and kind of turn to the side. You can make this side flush with this side, hit apply, and we can make this side flush with this side and hit apply. Then what we want to do is actually place this onto the fixture plate. And what I like to do sometimes is either make this plate invisible or change the material so it's transparent. And I'll show you both ways. If you want to make it invisible, you can right click and left click on visibility. And now notice you can't see it. Or you can click here, go down to a drop down and change it to something that's clear, maybe polycarbonate. You can do like clear polycarbonate. You can see that the stock material is clear. We'll talk more about the stock material in subsequent videos. So what I'm going to do now is just place the part down. I'm going to hit constrain. I'm just doing a mate, and I want to mate it not to the stock, but I want to mate it to the actual fixture plate. So what's going to be easiest, I think, is if we, for now, just make the stock invisible. Sorry about that. So we'll hit constrain, go here, and place this plate on here. You could see that we could machine a lot more than just this plate on here. And that's typically what we do is we machine multiple pieces at once out of a larger piece of stock. For now, though, we'll just place this in here. How about we place it kind of near the top so we don't use too much of the stock. We'll leave the bottom part untouched. But we do want to leave some of these screws near the top uncovered so that those will be hold down screws for the stock. And we'll talk about that in just a few minutes. So now that I've positioned that, it can help if you ground it. It's not necessary. It's not necessary to do that, but if you're worried about it shifting around and stuff, you can right click and hit grounded. Okay. Okay, now it is. I'm not sure why it didn't do it the first time. So now it's grounded. What we want to do now is set up the work coordinate system. And this is a little different. For the large machine, as I mentioned, this is the y-axis and this is the x-axis. The spacing on these holes match up with the spacing on the slots on the table, so we can bolt it down in this location, on this location, and this location. So basically, we can hold the fixture plate down with 6 screws, and we want basically this back left corner to be our origin of the work coordinate system. So what we're going to do now is maybe we should save it before we go any further. So I'm going to go File, Save As, and I'm just going to put it in practice parts. Notice it's saving this as an assembly, not just as a part. And we're going to save it maybe as, I'll just say gearbox um, plate, and then I'll go save. And once it's saved, now we can go to the CAM tab and set up the work coordinate system. My computer is running pretty slow, so just be patient as it's saving here. Now we'll go to CAM, Setup, and the first thing that we want to do is set up the origin not up here, but we want to set it on this point. And I think the easiest way to do it is just go to selected point. And we're just going to choose that corner there. Then, as I said here, the x-axis is actually going to be to the right and the y-axis is down. So I need to go here to model orientation. It looks like the z-axis is fine. So I'm going to hit x-axis and just select on that edge. And that's what we're looking for right there. where x-axis goes here, z-axis up, y-axis. Now the next thing that I want to do is select the actual model. So this is something new. Since we have multiple parts in this assembly, we need to tell Inventor what is the actual model that we're machining and what is the fixture, etc. So I'm just going to click here and then make sure I just select the model, not anything else. So I'm going to select that. Then the next thing I'm going to do is under fixture, I'm going to go down here and select this as the actual fixture or the piece that is helping to hold the model in place. Now I'm going to hit OK. Our stock really isn't correct because our stock, if you look at it, doesn't represent the big sheet that we have. And I'm going to go back to model for right now, and I'm going to right click and make sure that the stock is now visible. Go back to cam, double click on setup to get back to where we were before. And I'm just going to click on the next tab. And instead of having a relative size box or a fixed size box, you can actually go and click from solid. And then we can click whatever we want to be the stock. And what I want to be the stock is this. And now I can go OK. So that's the initial setup that we're going to use for this. And what I typically do is go back and make the stock invisible again. We'll talk in the next video about specific hold downs, and then the third video will actually go through the tool paths.